Hello guys, in this video we're going to write a level order traversal of a binary tree. We already do this in the previous video, but in that video I do this in terms of all-path function, and in this video I want to do this using recursion in terms of Zipwith function. So first of all, I will start with a writing simple helper. Okay, I tell that I will use a Zipwith function. But no, I will start with writing level traversal, and then I will rewrite this function. Okay. First of all, we have this battery data type here. It represents a binary tree. Exactly, it represents a full binary tree. It's a binary tree with some constraints. I didn't talk about this in the previous video, but we have these constraints. This tree, for example, can't represent a tree if they have exactly one children in this node. It can represent only nodes with 0 or 2 children exactly, and such a tree called a full binary tree. Okay. Let's start to write now a level traversal, and we start with a simple case. Then we have I will call it levels, and let's define type signature of this function. It has some battery A, and it on output produces a list of lists. So every element of this list is level. So level is represented as a list also. So we have a list of levels, and each level is a list which contains a node on this level. So the most simple case is then we construct our tree with a leaf constructor, and it's obviously that in this case we need to return our A node. Okay, and let's do this. It's simple. It's will work in this simple case. If we have only a tree which contains one node, obviously there is only one level, that's this node. But what if we have a tree which created with some node? We unpattern match it, this node. It have a value and sub left and right subtrees. And in this case, we need to take this node as an element of the level, and also we need to take our sub levels. We have on the next level we have only 2 branches because it's binary tree, and they need to take the sub levels of these branches and merge them. And for merging we will use a Zipwith function. So what I mean, okay, we have this levels function which give us a list of levels. So let's call this function for our left subtree and for our right subtree. Okay, and we will got this list. So imagine these two lists which contain levels, and we need to zip them, and we will do this with Zipwith function. And which function we will use here? Because our elements of our lists are lists, we must use the this concatenate function. So, and this should work, I think. Okay, let's try to reload this and run our levels with tr. And you can see that this works. We got exactly a levels of our full binary tree. And now, if you look carefully at this, there is a problem here. If I change this right subtree with leaf, for example with 8 number, and let's call our function again, and we can see that at this way some levels are not, the last level are not presented in our result. Why this happens? This happens because Zipwith function works not as we expected. So what I mean here? It means that it's only zip. It use zipping only using minimal elements of the list. Minimum list with minimum elements. If the second list has more elements than the than the minimum list, the other elements will be skipped. But I don't want this. I want that lists are joined and all the elements used. If there is no elements, I want to use an empty list for this joining. So you can see the Zipwith definition of the Haskell, and you will understand what I mean here. And let's just rewrite our Zipwith function. So I will call it Zipwith prime, or I know how this sign in English, sorry. And how we will define this function? It takes some function f, it takes some list which I unpattern match it, and second list which I also unpattern match, and how we construct a new list. We apply our function to our heads of the list, and it will be the first element of the list, and the tail of the list will be our Zipwith function with our f and tails. Okay, and also we need some corner cases, which when we have then one of the lists are empty. In this case we want to return a bigger list. So we have either here empty list, either here. And this Zipwith function should work as we want, I think. And let's change it here. Reload and levels. And you can see that in this case we take the correct levels, because our Zipwith function use all the elements in the list to do joining. It's not skip. Okay, so guys, thanks for watching. Push subscribe button, push like button, write comments. You can see, I will attach the link to this code, and see you in the next video. That's all, I think. Bye.